Alright, so we're going to go over this review guide that I passed out. I have pretty good confidence on this quest. I think we're going to do well. You're just going to take your time, think about what the question is asking, and go from there. So, question one. Let's circle each covalent compound. Look at the periodic table that I've somewhat striped here. If there is a compound that contains the striped atoms, any atoms bonded together from these striped sections, we're going to consider that covalent. Hydrogen, don't forget, is the exception over here. So when we go back, this one is ionic, covalent, ionic, covalent. Which one has both? The one that has multiple nonmetals and multiple metals or one metal is going to have both. So, KOH, the O and the H is covalent. The K is bonded to the OH. That's ionic. Number two, electronegativity. The higher the difference between the two atoms, the more ionic. So if you look at Table S, this is a question that basically tests your ability to use a reference table. Table S, you look at each atom and the difference in electronegativity between them both. This one would be 2.0. GE and BR is going to be 1.0. KBr is 2.2. And then GABr is going to be 1.2. So if I rank them from least to most, it's going to go 4, 3, 2, 1. Simple as that. Question 3. Why is this bond more ionic than that bond? Higher difference in electronegativity. Negativity. Got it. All right. So the higher the difference in electronegativity, the more ionic you will be. 4. Cations have a plus sign in the name. A cation is a positive ion. 5. Ionic compound. So once you've identified it as ionic, so that's going to be something from the unshaded section, the unstriped section with the stripes section. Please be careful when you are drawing these. Do not show bonds. This is when, since it's ionic involves a transfer of electrons. You need the brackets. You need to have the charges. Do not show them bonded together with a line. That is a no. Do not do that. Magnesium bromide. You'll notice you'll draw a magnesium dot structure. You'll draw a bromine dot structure. You're like, magnesium has 2 to get rid of. That means you need a second bromine. And would you look at that? It works. So I'm just going to draw this a bit different than the other one, but this is still an acceptable answer. You can draw it like this if you choose to, with them stacked on top of each other. I would prefer it in a straight line. Sorry, that says 2 plus. I would prefer it in a straight line, like how I did NAF, but if you draw it stacked just because you run out of room, that's fine. Polar bond and nonpolar bond. For the purposes of this class, for number 6, if it's different, it's polar. Different, different, different. Now in number 7, it's going to turn out that me choosing NBr might not have been the best choice. Number 7, you're going to answer exactly like you answered number 2. The more polar it is, the higher the difference in electronegativity you have. And when you look at Table S, you see that's 1.0, that's 0, because they're the same. Unfortunately, NBR is also 0. I probably should have chosen a better example. Carbon and oxygen difference in electronegativity is 1.4, and HF is 2.8. So if I were to rank them from most to least, this would be first, second, third. Since NBR is different, we're going to make that fourth. And since FF is the same, we're going to make that fifth. 8. Draw each one. Carbon has 4 free dots. Each hydrogen has 1 free dot. You can draw it like this. Or you can draw them with the dots being shared from each one to show that each hydrogen is sharing with its carbon 2, and each carbon is now surrounded by 8 total electrons. Remember, they want 8. Hydrogens each have 1. Sulfur has 2 to share because sulfur has 6 valence electrons. Don't forget, I think we got this, but to determine the valence electrons, look at the last number right there. Those are your valence electrons, just in case we forget. All right, so back here, scroll back down. Sulfur has 2 to share, so it's going to share those 2, which means you can also draw it like that. All right, boron trihydride. Boron's an exception. Boron only has 3 to share, which means it only needs to be surrounded by what it can support, which is 3 things. So don't worry about throwing on extra electrons on boron to get an 8. If boron only has 3 to share, boron only has 3 to share. Carbon disulfide. Each sulfur can share 2. Carbon has 4 lonely electrons, and those 4 lonely electrons need to bond with something. So we can share them with sulfur, and sulfur over here, making your final answer a double bond. So if you share 2, make sure you show me that it's a double bond. All right. Question 8, show the partial charges in each bond. You don't need to do it on each and every one. So for example, we're looking at the H and the C bond in the first one, the H and the B bond, the H and the S bond, and the S and the C bond. Here, we look at table S once again. Look at the electronegativity between the two. Whichever one is more electronegative will have this partially positive or negative symbol. So the more electronegative gets the negative one. The more electronegative gets the negative one. The more electronegative gets the negative one. And the more electronegative gets the negative one. Determine the shape of each compound in question 8. So this one is one of the ones where you have to kind of memorize those shapes. CH4 is tetrahedral. Boron trihydride is trigonal, planar. This one is bent. And that makes this one linear. That's something you just kind of have to memorize. Determine if the molecule is polar or not polar. So this means to be polar, you have to have uneven charge distribution. The charges must be distributed unevenly. You will only see that in two cases. One, the center has lone pairs, or the center is bonded to multiple things. Bonded to different things. Alright, so if the center atom has lone pairs, or the center atom is bonded to different things, then it is polar. The only case where we see a polar compound in the examples above is hydrogen, or sulfur and hydrogen, and H2S, because we have lone pairs here. You see lone pairs on the center, it's polar, because you have an uneven charge distribution. They are not canceling each other out. Okay? 12. Why do they not react? 8 valence electrons makes you stable. They don't want to react because they have no electrons to share. They have no electrons to share. So if you drew neon, you would notice neon looks like that. Doesn't want to share any of them. How many electrons will be shared between each atom below? So if you drew each fluorine, you would notice it has one free dot on each one. So this one has 2 to share. Oxygen has 2 free dots. This one has 1, 2, 3, 4. 4 electrons being shared. If you saw it as a bond and didn't think to draw the dot structures, each bond counts as 2. 2, 4, 6. 6 total shared. And that's it for this review packet, this review guide, barely a packet, not even a packet at all. If you have any questions, and we will go over more of this tomorrow, feel free to message me online if you have questions on the Castle Learning or anything that will be on the test. And have a great night.